Hello everyone, I hope you guys are having an awesome day so far. Today what we're going to do is we're going to apply what we learned yesterday. We learned Lewis dots. We learned how to draw the dots. So we're going to do that. And we're going to draw some bonds. And then I found a simulation where you're going to create a 3D model of each bond. So you kind of have a visualization of what each one kind of looks like. Okay, so the project is kind of a longer project. So this is the only video that's going to happen for today and tomorrow. Just try to get the project done. Okay. Today, well, it probably will take till tomorrow. If you have any questions throughout, let me know. I'm going to do an example problem here to show you what it kind of looks like. Okay. So this is what your paper looks like. Let me get my cord out of the way. Okay. Draw Lewis structures. All right. Oh, so it's pretty easy. All right. So draw the Lewis dot structure. So MG is in column 2. So remember, I got to do the bus driver. So I'm going to have 2 dots on MG. GA is in column 13. So there's going to be 3 dots, etc. Now, the reason we draw the dots is to draw bonds. That's our main goal, is to draw bonds. Okay. So if we have, let's say, what I like to do is, let's do a different one. Let's do CH4. Well, no, let's do CH4. Okay, so carbon has 4 dots. 1, 2, 3, 4. All right, hydrogen, I have 4 of them. 1, 2, 3, 4. Right? Now, everything wants 8 electrons. The octet rule, everything wants 8 electrons except for hydrogen and helium. Those all want 2 electrons. Okay, those only want 2. So we're going to be sharing, okay? We're going to be sharing bonds. So what I'm going to do is I'm going to draw a little bond between those two. So that those two share those 2 electrons. So now this hydrogen has 1, 2. It is satisfied. Let's share these 2. Share these 2. And let's share these 2. Oop, that's the long one. So all the hydrogens are satisfied. Let's look at this carbon. Carbon has 1, 2, 3, 4, 5, 6, 7, 8. Carbon has 8, which is the octet rule. Okay, so what you're going to do after this is you're going to get on a program that looks like this. Okay, and what this program is you can add lone pairs, you can add bonds, you can add everything. So what I want to show you here is this is the center element. So the center obviously is my carbon, right? So carbon has 4 hydrogens around it. Is there any bonds? Well, no. There's no electrons. So this is kind of what it looks like, right? And I want you to draw your 3D model. Okay, so the 3D model has 1 there, 1 there, 1 there. Okay. They all go together. It has 1 up. Okay. So this is what your 3D model should probably look like, right? This is what your 3D model would look like. Doesn't have to be perfect. And that's what it looks like. I'm going to go over one more example. And this example is actually going to be on your number 4. Okay, number 4, if we look here real fast, SI and S2. Well, SI is in column 14, so it has 4 dots. 1, 2, 3, 4. Remember, everything's trying to get to 8 except hydrogen and helium. Okay. Now, sulfur, I have 2 sulfurs. Each sulfur has 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So if I bond this and this and this and this, I'd be satisfied, but my silicon is not satisfied. My silicon wants to hit 8. So I got to join those two and those two. Okay, now my sulfur is satisfied. 2, 4, 6, 8. But what about up here? Well, this sulfur can bond with that one, and this sulfur can bond with the far one. Okay, that looks so crazy. But everybody has 8. If you look at the silicon, you got 1, 2, 3, 4, 5, 6, 7, 8. Okay, now what you see here is how many bonds are between the silicon, the center element, and sulfur. Good, there's 2. There's 1, 2. There's 2 bonds between those 2 elements. So when you go to draw it, what it's going to look like, I'm going to get rid of all these, is it's going to be a double bond. Okay, do you see that? And I actually have 2 of those. So this is what the 3D model actually looks like. Okay, 3D model has a ball, 2 sticks, a ball, 2 sticks, and a ball. It looks something like, let me pull it back up. Looks something like that, right? And that is what you're doing today. Okay, you're going to be, and tomorrow, today and tomorrow. So what I want you to do is if you have the opportunity to print it out, do that. If you do not, use Kami. Kami is a great tool to draw and analyze these pictures. Okay. So take your time on this. Okay. It's kind of important to understand how the bonding works so that we can work on like naming and other aspects of chemical bonds in the future. Okay. But if you have any questions, send me an email and I will get back to you as soon as I can. Like I said, this is today and tomorrow's assignment. When you're done, if you printed it off, you can take a picture of it and email it to me, or if you use Kami, just turn it in. All right. I hope you guys have an awesome weekend, I guess. And we will see you on Monday.